All right. So our goal today is going to be to try and tie together what we did on Monday. What we did on Monday was really algebraically, kind of theory based, to a more visual representation of vectors. So I want to make sure that you guys understand that you've got a visual representation for what we've been doing, for what's going on here. So we're gonna do a little bit of vector work both ways, and I'm gonna color code mine so that I can kind of see how the things match up. So I want to just give you a quick example here. So my intention is, I'll just show you how I'm going to do this. For each of these problems, I'm going to do kind of two columns. I'll do the algebra piece over here, and then I'm going to graph it over on this side. So I'm going to go ahead and get myself an XY axis set up here. If you've got enough space to go like 8 or 10 ticks in each direction, that should be plenty. And then again, I'm going to color code these. So I'm going to be working with 3 vectors in this first example. So use 3 different colors. I'm going to call them A, B, and C. So lowercase a with an arrow over it. So I'll write these down and then I'll pause so you get a chance to get caught up here. So A is 4, 3. B, we're going to go -2, 4. And then C equals A plus B. So I'll pause here for a moment so you can get caught up to me. I recommend that you color code them, and then I'm going to challenge you right now to see if you can go ahead and find C for me. I'm defining C to be those 2 vectors added together. We talked about how to add vectors when we met on Monday. Let me know if you need a hint with that. Who was absent on Monday? Okay, how would you think you would add these vectors together? If you had to guess, you do 4 plus 3 and get 7? No, you do 4 plus -2 and get 2, and 3 plus 4 and get 7. That's exactly how you do it. you nailed it. You could have invented this stuff. Oh, so glad you asked. Question is now, what's a vector? We're about to get into that. I'm going to make myself a little note of where this came from. This was 4 plus -2. And this was 3 plus 4. So we're just adding the components of the 2 vectors together. So the question was, what's a vector? Anybody who was here on Monday want to try and answer that? What is a vector? What 2 things do a vector contain? Direction and magnitude. And a scalar is just a magnitude. So a vector needs to have a direction and a magnitude, and we represent vectors graphically by drawing arrows, because the length of the arrow would represent the magnitude, and the arrow itself is representing the direction. So let's go ahead and make a vector 4, 3. Now remember, you can have a vector start anywhere you want to. It's just we need to travel 4 units in the positive x direction, 3 units in the positive y direction. I am going to choose to start my vector at the origin because it's pretty convenient. And then I can just find the point 4, 3 and draw an arrow to it. And am I going to get super? I'll just freehand it. That's close enough. That's A. So that is a representation of the vector. It could represent a lot of different things. It could represent how fast a pigeon is flying in the direction, right? It could represent the location of the nearest gas station from my home. How far away and what direction do I need to travel? It could represent a force that's being applied to whatever. All right, could you guys go ahead and draw me a visual representation of -2, 4 of our B vector? And remember, you can start it wherever you want. It just needs to go 2 units in the -x and 4 in the +y. I'm going to choose to start this one at the origin also. -2, 4. That would be my B vector. And while we're at it, let's do one more. Let's draw the C vector also. And I think I'll start mine from the origin also. 2, 7. All right, now what I'm hoping you're going to see here, maybe with a little bit of prodding, is that there is a relationship visually between what I've drawn as a red and a green arrow, the A and the B vector, and that purple one, the C vector. Does that look purple on that screen, or does it look blue? Well, at any rate, what's the relationship between A and B vector, the visual representation? We know the numerical representation was that we can add the components to get the components. What's the relationship between these two and this guy here? Anybody spotting it? What are you seeing? Kind of looks like they're added together and it's between them. I like it. What else are you noticing? It's the average of them. Okay, it's like the direction is kind of halfway between them. Like the direction looks kind of averagey. I'd say that the length here looks like it's longer than the average of these two, but the direction, yeah, I like that. What else do you notice? All right, so here's the big thing. Okay, I want you to pick up whatever you use for your B vector. I used red. And make me a dot with that at the end of your A vector, the arrowhead end. Oh, I hear some light bulbs turning on. What would happen if I redrew the B vector? So instead of starting at the origin, it started at the end of this one. So remember your B vector was -2 in the X direction, +4 in the Y direction. So if I went over 2 and up 4, look where I'd end up. I'd end up right at the end of the C vector. So one way that you can visually add vectors is you just take all of your individual vectors and you put them head to tail. So I start at the origin wherever I want my new C vector to start. I draw my A vector, and then right at the end of that, I draw my B vector. Because remember, you can draw these vectors wherever you want as long as they have the right components from wherever they start. Wherever that ends up, that's going to give me my C vector. Do you think it matters what order we add vectors in? Numerically, mathematically, would it matter if I had done 4 + 3 instead of 3 + 4? We still would have gotten 7. Graphically, does it matter? What if I had drawn my B vector first, and then from the B vector, I drew the A vector onto the end of it. Are we still going to get the same to the same spot? We would, because my A vector is over 4, 1, 2, 3, 4, and up 3. It would get me to this same spot too. So it doesn't matter whether I travel the A vector then the B vector or the B vector then the A vector, we're still going to end up at the end of that C vector. I saw a hand a minute ago. Did you have a question? Okay. If it comes back to you, then let me know. All right, we're going to do a new problem here. So let me set up a new XY axis. Hello. You're just in time. Thank you. How was it? Good. Was that your second one? Second math one? Good. All right. I'll give you my notes. We're using some, if you've got colored pencils or pens, I mean, there's markers in the back if you don't. We're doing a little color coding. All right, guys, we're going to make some vectors. We're going to make some kind of small ones, and this is audience participation time. So could y'all give me a vector, and let's keep our numbers like 1 to 4. We want to kind of keep them in the smallish range. Someone give me a vector. Make one of your components negative. -2, 3. That is a wonderful vector. Thank you for that. -2, 3. Well done. Go ahead and write that down, whatever color you choose to use there. I need another one. Who can top -2, 3? Come on. What? Say again. 2, negative. Yeah, let's not do that one. 2, give me something else. -3, 1. Hang on. You're making this hard on me now. -3, 1. All right, we've done a lot of examples with the X component being negative. Can someone give me a vector that's got a negative Y component? Darius, it's all you. What do you got? 2, oh, that's a good one. 2, -4. Awesome. Okay, we're gonna do this the other way around this time. We're not gonna, we're gonna start graphically, and then we'll come back and we'll add them up algebraically. So we're just gonna add all of these vectors together. So we're gonna start, I'm gonna do them in the same order that you guys gave them to me in. So whatever color you wrote down, -2, 3, go ahead and draw that vector. And let's do it starting from the origin. Remember, we can draw it starting anywhere we want as long as it goes to the left by 2 and up by 3. I'm choosing to start mine at the origin. That's going to get me this vector right here. All right, so now this next bit's going to be kind of interesting because we're going to add the other 2 vectors on, but I would like you, especially if you're sitting near someone, decide amongst some people sitting near you. I want you to see what it looks like if you do the red one next, then the green, or if you do the green one next, then the red. Okay, so I'm going to do the red one next and then the green, but find someone nearby you who's going to go the opposite direction. So if I'm doing this, I got to go. Now we're building this not from the origin, we're building this from the tip of the first one. Okay, so start here. I'm going to go -3, 1, 2, 3, and up 1, and I'm going to draw my second vector like this. Now some of you are going to be drawing the 2, 4 from there, but these should be lined up head to tail. Okay. And then draw the next one at the head of that one. So basically you've got 3 arrows that are all joined up head to tail. So this is 2, -4, 2, 1, 2, 3, 4. That's kind of interesting. So let me check I did this right. So I went left 2 up 3, and then left 3 up 1, and then right 2 down 4. And this is going to be my resultant vector. So fourth color, I need you to go from the beginning of your first vector to the end of your last one and draw me a new vector. And go ahead and write your component form for that final one. And I'm hoping we're all getting the same final component. Mine is, right. Can somebody who did it in a different order than me, can I borrow your paper so I can put it up on the screen and we can all see? Thanks, Graydon. Nice. Ooh, this got a little messy doing it the other way around. We got a lot of overlapping bits. So let me see if I can put these side by side. All right, so I went blue, red, green. Graydon went blue, green, red. And we both did our final one in purple, though. What do you notice about the final one? Same spot, isn't it? No matter which of those vectors what order we did those vectors in, we ended up at the same spot. So we can add these vectors in any order that we want. Can you verify? When I wrote down this vector here, I said it was to the left by 3 and up and down 0. That's where I got the -3, 0. And if we just done it algebraically? Totally. Thank you. All right. This is why I told you get a whole bunch of graph paper, because we're going to burn through it today. On to a new one. What next? Let me draw myself XY axis. So on this one, I'm going to draw 2 vectors for you. I'm going to ask you to do wedge notation for me. Let's go here. And here. And I'm going to give these some names. I'm going to say that this one down here is A, and this one up here is B. Actually, let's pause on writing down, because I want you to try this graphically first. This is a tricky problem, by the way. I feel like you guys are ready for this, so you got this. I want you to draw me the C vector, and I'm going to define C right now. Okay. So here's what I'm going to tell you about C. The C vector plus the A vector plus the B vector is equal to the 0 vector. Good question. What's the 0 vector again? So 0, 0 is the 0 vector. The 0 vector is the only vector that does not have, it has a magnitude of 0 and it doesn't technically have a direction. And I want you to try it graphically, but if it's not working out for you graphically, then by all means, feel free to translate this into algebraic and see what sense you can make of it. I'm going to give you guys a good 5 minutes to soak this in. If you're getting stuck, ask me for a hint or spy on a neighbor. So a couple ways that I saw people to do this. We'll do the algebraic one last, but this is what I saw graphically. So saw a lot of people do this. They said, okay, if I start at the origin and I do A and I add B, right? Because we're essentially adding A and B and C all together. So if I add B onto that, keep in mind B goes over 4 and up 2. So over 4 up 2 gets me to here from the end of A. This point right here kind of represents A plus B. Right? Now, if I add C onto that, where should I end up? I should end up back where I started from, right? Here's A plus B. If I add C, then I need to get back to where I started from. So I know that C is going to take me from this spot right here, and I'm color code it correctly. It's got to take me back to the origin. So that's what C is going to look like. Also recall that vector can be drawn at any location. So a lot of you drew the vector actually starting at the origin, and it was over, what was it? 1, 2, 3, 4, 5, 6 to the left and up 1. So a lot of you drew it like this instead, and that's correct also. But do you see this loop here that's got A plus B plus C? Are you seeing how that's getting us back to the origin, and that's how we got it to 0? I got to show you another one here. This is, I'm trying to remember exactly how you set it up, Jonathan. This was yours. Mine's getting a little messy, so I want to redraw it. Jonathan, you manipulated the equation here, didn't you? So did you move the A and the B over, or did you move the C over? You moved the C over, didn't you? You created a new variable. So essentially, if we manipulate this equation and we do minus C on both sides, this is going to seem kind of weird because they're vectors, but would you agree that this is an equivalent equation? A plus B equals negative C. All right, so Jonathan created a new variable for this called, use D. So Jonathan said, well, let's say that A plus B equals D. What's going to be the relationship between C and D? They're not the same as each other, but if I go the opposite of D, I'll get C, right? So we're going to do A first. My A was my orange one. Where's my orange marker? So A was over 2 down 3. And at the end of that, we'll tack B on. And B was over 4 up 2. So there's A plus B. And then D then would be this vector here that takes us from the beginning to the end of those two added together. But D is not what we're looking for, right? We need to flip it over. We need the opposite of it. So instead of going to the right and down, I'm going to go to the left and up, and we would end up with the same vector that we came up with a second ago. All right. How are we feeling about this so far? All right. Is this helping kind of with the whole idea of vectors? I hope that it does. We're going to do one of your homework problems together right now. So if you do your homework in a different place, go ahead and get that out. All right, this is on page 511. If you happen to have your book with you, it would be helpful. Yeah, guys, get your books out. And I'm going to have you do, as part of your homework, I'm going to have you do 13 and 19 odd. let's do, and then I'll just give you the rest of the assignment now. 22, 26, bless you, 32, 38, and 44. But I'm going to give you some specific instructions for 13 to 19 odd because you already did these in your homework last time. See ya. I want you to do these graphically. So we'll pick one of these, 13 to 19 odd, and I'm kind of thinking maybe 17 looks like a good one. Yeah. Nah, let's do 19. We'll do the last one. We'll do 19. 19 asks us to do negative 2u minus 3v. So you've already done this. They gave you u and v. For those who don't have your books on you, I'll go ahead and write them in here. U and v were negative 1, 3, and that's u. And v was 2, 4. Again, you've already done this problem, but I want you to do it graphically. Okay. So, and we're going to need a pretty big grid here. So again, help yourself to graph paper on your way out today if you need to. We're going to be multiplying some stuff by 3 times 4 is going to be 12. We're going to need a pretty big grid for this, but that's all right. We got this. Lots of space. I'm going to color code this. If you're doing yours at home and you don't have markers or something to color code, just use like dashed and dotted lines would be a good way to do it. All right, so I'll kind of walk you through this, and then this will be the most complicated of those 4 that I'm asking you to do graphically. The rest of them, by the way, you can do algebraically or graphically, your choice. But I want you to go back and redo these same ones graphically, compare it to your answers, and make sure you're getting the same answer. So I'm going to do u. I'm going to do u in red. So negative 1, 3. Put a little u on there. This could end up getting kind of messy, guys, but that's all right. We're tough. And then I'm going to do v and I don't know, blue. 2, 4. Oh man, I did not leave myself enough room here. Yeah, maybe. We might be all right. 2, 4. All right, I'm gonna let you catch up. I don't want you to miss the next part here because we haven't done this yet graphically. If you're all ready to go, I want you to think about this. What does it mean when we do a negative vector? The opposite of it? How's that gonna look graphically? How is negative u going to look different from u? What do you think? Mm-hmm. Like D and negative C from earlier. Yeah, they're going to be in the opposite quadrant, facing the exact opposite direction, right? What about the lengths? Is negative u going to be the exact same length as u? Same length, but just in the opposite direction. So I'm actually going to next do negative 2u. Negative 2u. So I'm going to do this, but I'm going to do the opposite and multiply everything by 2. All right, so 2, you went to the left and up. I'm going to go to the right and down. You went 1 to the left. I need to go 2 to the right. It went 3 up. I'm going to go 6 down. So 1, 2, 3, 4, 5, 6. And I'm going to do it as a dashed line. So this is negative 2u. So if I did that right, then that dashed arrow should be twice as long as the red one, but facing in the exact opposite direction. Does it look like I did that right? I wonder, I'm just thinking out loud here. I wonder if it would make sense for me to draw a little arrow here as well. Here's 1u, here's negative 1u, here's negative 2u. I don't know. What do you think about that? Does that make it too busy and confusing? Or do you think that's helpful? Here's negative 1u and here's another negative 2u stuck on top of it. All right, I'm going to try and do the same thing for v. So I'm going to do negative 3v now. So I'm going to go the opposite direction. Actually, I'm going to try doing it this way that I don't know. That seemed to work pretty well for me. So I was going right 2 up 4. I'm going to go left 2 down 4, but I'm going to do it 3 times, right? Because we got negative 3v. So there's 1, left 2 down 4. There's 2, left 2 down 4. There's 3. So there's 3 copies of my v vector, but going in the opposite direction. All right, we're about ready to finish this up now. What do I need to do with these 2 new vectors that I just created? We're just going to add them together. That's what we got up here. It's negative 2u plus negative 3v. So we'll just add them together, and I'm going to do it graphically. So I need to go head to tail again. So I'm going to redraw my negative 3v vector, but I'm going to start it here. So over 2 down 4 3 times. Over 2 down 4. Over 2 down 4. Hi, come on in. Down 4. And that gets us our final vector, which is hugely negative. Man, it's a good thing I got a giant stack of paper back there for you, graph paper for you. Holy cow. Let's count here. Let's see here. 1, 2, 3, 4. And 3, 4, 5, 6, 7, 8. Can someone, when you get a chance, look at your homework from Monday, look at number 19 and see if that matches the answer that we got when we did it algebraically? It does? Yes! Right. Cool. All right. Is anybody really annoyed that I'm making you do these graphically? Yeah. Okay. Well, that's fair. I appreciate your honesty too. You only have 3 more to do though. Okay. Use my graph paper. I got stacked back there. So if you don't want to use your own, feel free to use mine. And the good news is that the first couple you're not multiplying anything. So you got 1 more that's going to take up a lot of space. But the 13 and 15 should be much smaller. So that's your assignment. You guys got a little chunk of time. Not much. I'm sorry. I did check homework, so I'll come set 3 from the review, and then Monday's homework. If you've got those, I'll be with you in just a sec.